This question is asking, are there differences between first-generation quantum networks and next-generation quantum networks topologies? So what's the difference between these types of networks? What makes one first generation versus next generation?
Danny, I'll let you take and run that one.
So there definitely are some differences between the first generation quantum networks we mentioned and entanglement-based quantum networks. So while there is some overlapping hardware between the types of networks, there's definitely some hardware required by entanglement-based quantum networks that's not present in previous generation quantum networks, such as entanglement sources. And differences in hardware, technology, topologies actually is going to make a big difference for performance and applications. So like we mentioned, previous generations were limited to being single purpose, and we've seen that entanglement-based quantum networks are very much multi-purpose. Beyond that, previous generations of quantum networks require the use of relay nodes, trusted relay nodes, to enable longer distance communication. In order to scale their size, they need to use trusted relay nodes. And if a trusted relay node becomes compromised, so too is the quantum information that gets transmitted by it. So the thing with trusted relay nodes is the name's a little bit misleading. It's not a relay node that you can trust. It's a relay node that you need to trust. And if you need the quantum information that you're transmitting to remain confidential, then these trusted relay nodes can be a potential big vulnerability. On the other hand, with entanglement-based quantum networks, we can use repeaters, which we've talked about today a little bit, for longer distance communication in order to scale up the size of our entanglement-based quantum networks. Even if the repeater becomes compromised, the quantum information that is going to be transmitted by it won't become compromised. And this is in part true due to something we mentioned earlier, that you can use quantum teleportation to communicate quantum information to the endpoints on the network without having that quantum information actually ever being exposed on the network itself. And so in this way, the security of the quantum information on our entanglement-based quantum network is what we call device independent. So there are definitely some differences in the hardware, topologies, and things like that. And those differences do make a big difference when it comes to performance and applications. And we've seen that a little bit today.